Welcome to the first in what I hope will be a series of debates I'm calling the Open Society Debates. It's hosted by our group, Philosophy and Reason, that meets up on Meetup. A reminder that the debate's being recorded, so please don't pick your nose, and if you're here and you should be at work or something, make sure you stay out of camera shot. Let it be resolved that man-made climate change is real. The science is done, and we must act now. That is the moot for the debate. Our fantastic speakers for tonight will be introduced by Brigitte shortly. But I want to start with a few thank yous. The first thank you I want to give is to you. I want to thank you for being here, because you being here means you're here to listen. Next, I want to thank our speakers, John, Ian, David and Joe. They will be introduced to you formally, but I ask that you give them a round of applause right now. To echo our thanks to them for giving us their time so we might learn and progress, because that's what we want to achieve. I'd also like to thank my co-conspirator in plotting our group, Brigitte, our moderator for the night. She's a brilliant woman and I love every discussion I have with her. Thanks, Brigitte. A special thank you needs to go out to Lindsay and his team, Ali and Clayton from Freedom Media WA. Not only are they streaming tonight's event, but they are serving us all through their tireless efforts to report news independently. A media source that can't be bought and that won't deal in favours. And so I encourage you to give Lindsay and his team a round of applause as well. You can find them, like and subscribe to them on Facebook, YouTube, Rumble, Instagram, and they also have a website, freedommediawa.org. I also need to thank the others who have assisted me here tonight. Wes, Tom, Peaches, Paul Jones, my good mate, the Belmont RSL for making this facility available to us, and also my darling wife who was out there on the front desk. I'll hand you over to the moderator for our debate and we can get things rolling.
Thank you very much. I will now ask our first speaker. The moment I will give that signal, I will be counting then the 6 minutes. So please, Professor Newman, if you would come to the podium.
Can I start? Right. So the three things: man-made climate change is real, the science is done, we must act now. The real reality, I mean, we all have our own realities. I don't particularly like the Twitterverse reality, but nature is a reality, and nature is talking to us pretty clearly now, and certainly around the world, the floods and fires, the unprecedented changes in climate are showing us that climate change is real. Man-made? Well, in the IPCC, the statisticians look at all the different things that could be causing it. There's only 1 in 100,000 chance that it could not be man-made. So I think the science is done. Let me just show you what we do in the IPCC. That is one of the books that we produced that I was part of. I've been involved for 10 years in IPCC. There are about 7,000 scientists who get involved. We are all volunteers. We are not paid to do this. And this particular one that we've just finished, the mitigation report that's just come out, There were 65 countries represented, 278 writers. We reviewed comments from 59,000 different people, and every question was answered. So what we do is make sure that the science is right, and every single thing that is raised we look at. If you don't have time to read a book like that, and really who does, there are plenty of ways of getting summaries of it. There's one very good website that I like, it's called Skeptical Science, which looks at all the myths about whether the science is clear or not. For example, David has 17 myths that are analysed on that site, and that's the kind of thing that it does. But I don't want to spend time on that, because the key thing for me is we must act now. Now, actually, I don't quite like that statement, because it makes it seem like we haven't started and that it's all very, very hard. I've been involved in this, in the changes that are needed for some time, and there's so much happening. It's as though it's almost beyond belief, the changes that are happening now so rapidly. So my message is, don't despair, don't be anxious about it, because there is enormous change happening. Let me tell you a few things. Solar is now the cheapest form of energy the world has ever known. Even 5-8 years ago, to put solar on your rooftop, 6 kilowatts would cost you $20,000. It now costs $2,000. It's come down around 90% in 10 years. So the second thing is that gas is now the most expensive form of electricity, and the second most expensive is nuclear. So you can see why the utilities are desperately changing to using solar and wind. Batteries and electric vehicles are following the same trajectory down, very rapid declines as they become more and more available to us. So when you put solar batteries and EVs together, you can get rid of 80% of the greenhouse gases, and it's cheaper and it's more effective. So why wouldn't we? It is happening now. Now, we do need to do other things, and over the next 10 years a lot of new things will happen with hydrogen and ways of feeding cows seaweed and so on. But the big thing driving it is there's $170 trillion in the finance world available only for net zero projects. So everything has to go net zero. So all of our mining companies, they're all switching very quickly. And that is the kind of process that's setting in that is driving it. Not just by governments, but by money, because it's cheaper and better. That's a big change. Now, what about WA? Are we going to be a leader or laggard in this? My sense is we are already a leader. The lithium that is used for lithium-ion batteries around the world, half of it comes from Western Australia, and that is growing rapidly. There are 8 new lithium mines started up, and it's a boutique kind of mining operation, so it's a lot easier to actually treat it, process it here. So we've got 3 new processing plants started up, 2 in Kwinana, 1 in Kemerton, which are processing to 99.99% pure lithium hydroxide, sending it straight to battery manufacturers. We've never done anything like that before with our minerals. That's the kind of thing that is happening because we've got all the battery minerals here. Now, there is a bit of a myth around that we're going to run out of battery minerals. For some reason, the limits to growth is being suggested as being applying to that. It never did before, but this is coming from oil companies. It is very important to see that we are going to make that. And the final thing is, last weekend, we broke the world record in how much solar from rooftops is going into the grid, 71%. We have so much rooftop solar happening here that it is showing the world that you can change quickly. So I think we can show the world how to change, and there's no reason for us to be depressed about that. Thank you.
Sorry. The next speaker. Sorry. My timer.
Now, and I'll be able to see the slides, or?
Yep.
Good evening, ladies and gentlemen. The climate debate is at a strange point, and part of that is that I've got 6 minutes and I'm going to have to debunk 20 years of propaganda, so there's a challenge, strap yourself in. We're at a strange point in this debate, and I did have a slide there of windmills, because we're at the point where as a society we're suggesting we're going to build lots of windmills, we're going to spend billions of dollars, and we have already spent billions of dollars, and the reason we're doing that is because we're hoping it will slow storms for our grandchildren 100 years from now. If we build enough, if we put enough solar panels on, will it stop floods in Bangladesh? How many panels do you think we need? It's a tricky question, and not many people join the ends of this debate together. Now, I want to go back to the start, which is the evidence. If we're going to spend billions of dollars, why don't we look at the question really hard? Is CO2 really affecting the climate? Because everything depends on that. And there's an enormous industry. There's $270 billion of carbon trading around the world. There's $770 billion in investments in the renewable transition. How much is invested in figuring out whether the climate models work, whether CO2 matters, whether CO2 really is the prime driver? Now, a lot of the things you'll see in this debate are down to name calling. If the evidence is so overwhelming, why does anyone have to resort to the term climate denier? Now, and I'm glad to see, of course, Professor Newman didn't do that tonight, which is great, but it is a common thing in the debate, isn't it? We hear it all the time. A lot of this debate is about bluff. It's about convincing you through righteous indignation that you shouldn't have any other opinion or ask any hard questions. So even Nature, can you believe, supposedly the most esteemed science journal, has published papers of lists of scientists who get too many mentions in the media. It's a blacklist, a suggestion of those who should not be heard. I'm on it, David Archibald's on it, my husband David Evans is on it. Isn't it about who's got the best arguments and not who's got the right to be heard in the media? Shouldn't the media be covering the people with the best points? Not the people with the most papers necessarily, but the points that win the debate. Now, they'll tell you there's a consensus, and there certainly is, I won't deny that, but that's argument from authority. So we've moved from an ad hominem argument, because we're here in the philosophy and reason group. We've moved from the ad homs, calling people deniers, trying to intimidate them into silence, to there's a consensus, which is argument from authority. And we've known for 2,000 years that this is not the way to reason. And we also know that argument from authority or a consensus could be a proxy for the amount of funding that you've put into one side of the debate. Ladies and gentlemen, we paid to find a crisis, and we got what we paid for. If you spend enough money asking scientists to find a problem, they'll publish papers, they'll find a problem. But if you don't spend money asking them whether the models are right, whether the sun could be controlling climate change, then you haven't necessarily spent your money well. You've got monopoly science. So we have a big problem. Looking at the evidence for climate change, we see a lot of evidence for warming. There is warming. It has happened, and carbon dioxide is a greenhouse gas. But what we don't have is evidence that carbon did it. And that's quite hard to find the evidence. There's specific evidence that carbon is responsible. We're a water planet. The water is the most powerful greenhouse gas on the planet. It does something like 3 times as much of the effect of absorbing those infrared rays and emitting them to space that carbon dioxide does. Water is by far the most important thing. But climate models are really quite bad at water. Let's have a quick look, really briefly, at a big experiment that hasn't been reported much. In 2005, a huge US report said this was the fingerprint of greenhouse gas warming. We call it the hotspot. The graph shows in the middle there, the big red area, that's 10 kilometres above the equator. And the North Pole's on one end and the South Pole's at the other, and you can see most of the warming that is caused largely by water vapour, not CO2, is from that warming 10 kilometres above the tropics. This is the hotspot, and it was described as a fingerprint over and over and over. It would define that the warming was caused by greenhouse gases, even though it was mostly H2O, we didn't want to mention that. And what they found with 28 million weather balloons was this. Have a look at that. 28 million weather balloons looking through the atmosphere over 40 years found nothing. None of that warming that was supposed to be there was there. And they've spent the last 15 years since that, so they've known for 15 years the pattern wasn't there. They spent the last 15 years rehashing that data from 1979 to 1999 over and over again, hoping to find that there was actually a hotspot. So, ladies and gentlemen, the tally of failure is extensive. And in fact, it's actually quite difficult to sum up. They got the Arctic right, but the Antarctic wrong. Is this global warming or is it only hemispheric warming? They fail on the rainfall, the floods and the droughts. They can't predict El Niños. The largest driver of our climate is the El Niño effect, the La Niña effect, and our climate models can't do that more than a few months in advance. How are we supposed to predict the climate 50 years ahead when we can't do it 18 months in advance? So we can't predict the climate on a local, regional or continental scale. The models get the core assumptions wrong. The hotspot is missing. It's the only fingerprint they said that mattered right up until they couldn't find it. They can't explain the pause. They can't explain the cause or the long-term historic climate movements either. Measurements of satellites, cloud cover changes, 3,000 ocean buoys, 6,000 boreholes, 1,000 tide gauges, 28 million weather balloons looking at humidity and temperature and other things don't find what the models said they should. Ladies and gentlemen, scientists are behaving badly, calling people names, they're hiding declines, they're hiding data, adjustments and their methods. The Bureau of Meteorology will not let us replicate their Australian data set in full with full methods. Thank you.
Before I begin, does this adjust? Because I've got quite a quiet voice.
Just one moment. So I think can we start?
Yep.
No? Just 1 second, technical issues, obviously. Forgive us.
I should have had some jokes to tell while I waited.
Yes.
This isn't being streamed, just to let you know, so we've just got to re-establish the connection.
Okay.
All right. We'll just wait for that if we can.
Is this okay?
We'll give it a couple of minutes.
So is the system overheating?
Yes.
Thanks.
Yeah. I think.
David, people that might be here involved. So the first warning is the actual end.
Yeah.
Okay. Apologies, everyone. We're ready to go again. Thank you very much for your patience.
Begin. Good evening, everybody. I'm here to give you the perspective of a local government councillor. I should begin by saying I'm not representing the City of Swan. I'm just a councillor giving you my own opinion. I'm not going to debate climate change. I'm here to tell you what we're doing about it. A local government councillor, believe it or not, is an influential strategic role. And I was once talking to our former Commonwealth MP, Ken Wyatt, before he was a Cabinet Minister, and he said how much more influence a councillor had than a backbench MP, and that quite surprised me. As councillors, we have to take a strategic view of the future of our city, long into the future, looking ahead 20 or 30 or 40 years. The next three slides are slides I showed our councillors after I attended a climate change conference. So basically it's a recap of the greenhouse effect. Basically visible sunlight passes through the atmosphere, warms the earth and is re-emitted as infrared radiation. Some of the infrared is absorbed by CO2, warming the atmosphere. The more CO2 you've got, the warmer it gets. And this graph shows the increase in CO2 since about 1960. You can see it's going up. And the temperature of the earth is increasing, as you can see from that graph. So those are the simple facts I gave to our council. Basically, it's a real phenomenon. The Intergovernmental Panel on Climate Change reports, which you can see examples in front of you, are created for government policymakers. And as councillors, we are policymakers. We need to take notice. And I read this in an IPCC report. It spoke about this, and it said, and when local and regional governments and decision makers are supported by national governments, what that said to me was, as a local government, as a local councillor, I needed to do something about it. So we did. In August 2019, we recognised a climate change emergency. We didn't actually declare one. The resolution was that the City of Swan lobbies state and federal government to recognise that a climate change emergency exists and action is required. Fast forward to October 2019, I was up for re-election, and in my 150 words statement, which I put in bold and outlined in yellow therefore, I said I will advocate for net zero CO2 emissions by 2050. Well, did that get me into a lot of trouble? All sorts of people contacted me about this, and they said, I would have voted for you, Ian, except for your net zero CO2 goal. But it seemed, actually, that the silent majority was right. The more people liked it than disliked it. I first got onto council with a margin of 100 votes. The second time round, a margin of 2,000 votes, indicating that the net zero CO2 goal is valid. I went along with fellow councillors to a National Climate Emergency Summit in February 2020, but then shortly afterwards, in March, we got a completely different emergency. Later, I gave the presentation to council that I showed you earlier on. And then in 2020 later, I moved a motion to report on an action plan for net zero. It got knocked back because the report would have cost $60,000. In January 2021, the Sustainable Environment Strategy came to Council without a net zero goal. Council resolved to send it back out for community consultation. October 2022, earlier this month, we finally approved our Sustainable Environment Strategy, and that includes a plan for net zero by 2050. And what you can see here is the Sustainable Environment Strategy shows that responding to the goal of net zero emissions is good for our ratepayers, as it actually has a good business case. The break-even point is just 9 years away, and we've got plenty of other projects that have been going for 60 years that haven't broken even. This is quite a complex slide. It's a marginal CO2 abatement cost curve, and what I want to draw your attention to is that big red box. That's the CO2 saving from LED streetlights. And next to it, the yellow box is CO2 saving by putting photovoltaics on city offices. So that is actually most of our CO2 emission. And these are relatively simple, straightforward things to deal with. It's going to cost $10 million to replace the streetlights with low energy consumption LEDs. And it will save us $50 million in electricity costs over 10 years. It's an easy decision for us to make. The next big one is photovoltaics to power our city offices. This is also, as you heard from Professor Newman, extremely cost effective. Our plan is for 2050, but the plan for 2030 would be the same, only done in 7 years, not 27. I believe we can do it in 10. I believe we can do it by 2033. Net zero CO2 emissions by 2050, and we won't have to put your rates up. As a council, we found that net zero CO2 goal will save money, and that means we'll be able to potentially reduce rates or increase our services. Now, this is not an outcome I expected from a net zero CO2 policy, but it's most welcome to me as an elected representative, as it will be easy to explain to the community at my next election in 2023, and I'm quite looking forward to that. Finally, what if it's all a terrible mistake? Even the IPCC reports talk about probabilities and confidence levels. If you've ever read one, you'd see every sentence has a probability and confidence level in it. Well, think about what it might be like in 2050 or 2033. Your rates will be lower in real terms. There'll be loads more trees. There'll be far less pollution. There is no risk to local government or ratepayers in working to a goal of net zero CO2 by 2050. Thank you.
Thank you.
What stops the Earth from looking like Pluto? It is energy from the sun. The sun's energy does change, and our climate follows. Back in 2007, when we were in solar cycle 23, I predicted that solar cycles 24 and 25 would be weaker and that the planet would be cooler. That has come to pass. Peak temperature was in 2016, and we've had 6 years of cooling since. If we look at Australia's temperature record, it is absolutely flat. For 44 years, nothing. 2/3 of Australians alive today haven't experienced climate change. We are gathered today in the city of Belmont, which declared a climate emergency. If that flat temperature record gets you excited enough to declare a climate emergency, you might be a bit special. But not special in a good way, more in a special needs sort of way. There was a pleasant and much appreciated warming of the planet in the second half of the 20th century. So what caused that? From 1933 to 2006, the sun was more active than it had been in the previous 11,000 years. That is now over, and our world is going back to conditions of the Little Ice Age. What of carbon dioxide? The greenhouse effect, which is 80% water, keeps the planet 30 degrees warmer than it would otherwise be. So the average temperature of the planet is 15 degrees instead of minus 15 degrees. Carbon dioxide contributes 10% of that, or about 3 degrees. The carbon dioxide level prior to industrialisation was about 300 parts per million. If the relationship is 1 degree for every 100 parts per million, and the concentration is going up at the rate of 100 parts per million every 50 years, that's 2 degrees each century, and we would fry. But carbon dioxide's heating effect is logarithmic, not arithmetic. The first 20 parts per million contributes 1.2 degrees, and then the effect drops away rapidly. So that from here, each 100 parts per million only heats us up by 1/10 of a degree. And that is lost in the noise of the climate system. Carbon dioxide is tuckered out as a greenhouse gas. Its effect is minuscule. It is not a real problem. Also consider that at the bottom of the last glacial period, only 15,000 years ago, the carbon dioxide level got down to 180 parts per million. Plant growth shuts down at 150 parts per million. We came within 30 parts per million of disaster on this planet when all life above sea level was wiped out. Fossil plants from that period showed signs of carbon starvation. For plants, we are still at starvation levels of carbon dioxide in the atmosphere. The more we can raise carbon dioxide levels, the safer all life on this planet will be. The real problem is that the unhinged concern about global warming has led us down a dead end in energy policy. The renewables we see around us, solar panels and wind turbines, are made using cheap coal power in China at 4 cents a kilowatt hour. Under ideal conditions in the Australian desert, solar panels produce power at 21 cents per kilowatt hour. You can't make more solar panels with power produced from solar panels. They are neither renewable nor sustainable. They are an artefact of cheap coal power, which is ancient history, given as what is happening to international coal prices. What Australia should be doing is converting our low-grade coal to diesel and petrol to keep our economy going. That is absolutely necessary given how fractious the international situation is coming. Each day's delay puts us deeper in danger. One day our fossil fuels will run out, and we should prepare for that day. If our grandchildren have any sort of standard of living at all, that ideal future is sodium-cooled breeder reactors powering the conversion of biomass into the thousands of different hydrocarbon molecules that a modern economy runs on. That is the ideal future, and the only possible future worth living. If we stray from that path, it is back to horse-drawn carts, disease and destitution. Vote this evening as if your grandchildren's lives depend upon it, as they most assuredly do.
We have now a second turn for every speaker, this time only 3 minutes, and we can hope that our speakers can address the points of each other. So a debate situation now. So we start again with Professor Newman, and we go then through to the speakers as we have done before.
I'll just pick up on a few points. The idea that the best future we can have is to burn every drop of fossil fuels in order to get enormous amounts of CO2 in the atmosphere is crazy. And if you look at any of the data on what is happening with that greenhouse effect, it's not the effect on the plants. The plants, sure, they will keep growing better with more CO2. That's what happens in a greenhouse. But it's the temperature that goes up in the atmosphere because we are getting more heat into the atmosphere. That's what's happening. And the heat is there and it is being measured more and more. And that's why we're getting more extreme events all the time. And that's our problem. So that issue is dealt with in all of the reports. We need to get rid of fossil fuels, and we have a better solution. That's the reality. So we don't have to wait for breeders. We aren't going to go into poverty. The new technologies work better, and that is showing out all the time. The stock markets are showing that those companies that are going into this, and many of them in Western Australia are doing it, are going well. And the countries and places that commit to that economy will be the leaders, and they will provide for our grandchildren into the future. The issues of the more CO2 the better are clearly not the case. The idea of that most of the points that David are making are dealt with in IPCC reports, so I can't go into them in any great detail, but the ideas that Joe is suggesting that the models aren't able to understand, that is largely true. We're getting better at modelling all the time, and the modelling is starting to show, as in all the weather predictions, that we are getting a better understanding of that. But the reality is that changes are happening so quickly. The extra energy in the atmosphere is changing weather patterns, so you can't just depend on what happened before. This is the world we're going into, and we do need to get away from that increased CO2 in the atmosphere, because that is causing these.
Can I just say again, please try and refrain from commenting, etc. We're here to listen, and I want us to be respectful and appreciative of everything that's been presented to us. We will have a chance for questions later, so thank you.
A moment, we'll just make sure that you have your full time.
Yes, I want to shortchange.
Thank you. Where to start? Ladies and gentlemen, we have always had floods, fires and droughts, and a lot of our history is being denied when we say that today's extremes are unusual, because when we look at even our best short-term records of things like hurricanes going back years, cyclone energy around the planet hasn't changed. The sea levels are rising, but it's at about 1 to 1.5 millimetres a year, according to 1,000 tide gauges, as Beanstalk et al. And Niels Axel Morner showed it was similarly 1 millimetre a year when you look at stable crustal plates. So things are not changing anywhere near as quickly as we believe. In fact, there were floods in Echuca in 1870 that lasted for 2 months, that filled the river as a vast ocean, and Melbourne was called the Venice, the Antipodes Venice. So it's all happened before. There were fires in 1851 that were so bad in Victoria. The Black Thursday fires burnt 5 million hectares of area. The smoke filled the skies. It was black, and apparently Aboriginals knew and said that this has happened before, so they were used to that history of devastating fires. Australia has always been like that. And all you need to do is search the Trove archives to find the history that's forgotten. Now, as far as energy goes, the other thing is, when we look at energy, the big question is not the simple studies that say gas or solar is cheapest based on singular 1 hour measures of what it costs per hour. It's what the whole system costs. And that intermittent energy is some of the most expensive vandalistic energy on the planet. When you look at the whole cost retail customers pay, there is no country on earth that has cheap electricity and lots of intermittent renewables. Hydro is a renewable which can be cheap, but when you look at solar and wind and you graph the capacity of solar and wind per capita, and look at the cost per capita, it's always a straight line. It's a linear graph. The more solar and wind you have, the more expensive it is. The subsidies to it include transmission subsidies, subsidies which are direct subsidies. If the stuff is so cheap, why do we need to subsidise it? The Australian government spends about $5 billion and the state governments about $5 billion a year subsidising it. If it's so good, why do we need that? Why do we need a $270 billion global carbon market if this stuff is going to outcompete everyone? Hands up who remembers all the subsidies for mobile phones and the internet? Everyone? We didn't need to subsidise them because they were competitive, they were good. You look up data coming out on the long-term costs of most of these things, and the cheapest electricity, according to the AEMO last quarterly report, was actually brown coal in Australia, and it was it was winning bids at around $20 a megawatt hour, which is 2 cents a kilowatt hour, and that is this year, during this year's extraordinary prices, when brown coal set the price of the Australian national grid on the East Coast. The prices were so insanely cheap. We had energy for 3 cents a kilowatt hour as a wholesale price for decades, based on mostly coal. Ladies and gentlemen, thank you very much for the chance to talk today, and thanks for thinking.
Look, that was very interesting. Just to address something Joe raised, is CO2 really affecting the climate? I guess we can all remember the recent Warraloo fire that impacted so many homes in the city of Swan. So as a council, we had to declare an emergency over that. And I was there also as a volunteer firefighter. So I saw it from two perspectives. At a distance from government and close up as a firefighter, it's quite serious. I was also at the Waroona fire. That was like fighting a war. It was that big, the scale of it. And we only have to look at the rain over east to see how serious this is. If it's not CO2, what is it? The next point is Dr. Archibald mentioned that for every 100 parts per million of CO2, we get just 1/10 of a degree of warming. Is that correct, Dr. Archibald, or did I mishear? What? For every 100 parts per million of CO2, we get just 1/10 of a degree of warming.
It's your log graph.
Is it your log graph?
You're referring to?
What?
I think you're referring to his log graph about the effect, the direct effects
Yeah, that's
of
right.
CO2 being added.
Okay, so let's assume that's a correct statement. 90 million years ago, there was 1,000 parts per million of CO2 in the atmosphere. So that's 600 parts per million more than there is today. So that means it would have gone up by 0.6 degrees C, according to Dr. Archibald. People often say that you don't produce your evidence. Yeah. Well, here's some evidence. I've got a copy of Nature magazine from October 2020. And on the front page, you can see dinosaurs at the South Pole. So these are facts. So 1,000 parts per million means dinosaurs at the South Pole, but it won't be these kinds of dinosaurs. It'll be a different kind of dinosaur. So I think it's real. And as for the photovoltaic argument, photovoltaics pay themselves off in 6 months. That's the payback period. So I think we're dealing with a real phenomenon, and we need to address it in a business-like manner. Thank you.
And thank you, because you've given me something to talk about. Oh. Okay, the planet. Our planet started out 4 billion years ago with 80% CO2. No, it was 80% nitrogen, 20% CO2. And then a billion years later, the plants evolved and we had a lot of algae, and it sucked all the carbon out of the atmosphere. And since then, since about 2.5 billion years ago, the carbon dioxide level's been very low. It used to be 20% of the atmosphere, now down to 0.004%. Then the plants evolved, but what's happened in the last 600 million years, we've had a number of glaciations. The CO2 level went up and down. But over time, it all got locked. A lot of that carbon got locked up in the sedimentary piles around the planet, including in the breakup of Pangaea and Gondwana. You suddenly had a lot more continental shelves. Limestone was deposited, limestone CaCO3, took down all the carbon dioxide out of the atmosphere. And that's why we're down to starvation levels for plants. Now, 90 million years ago in the Eocene, the flowering plants evolved. And they were evolved in an atmosphere of 1,200 parts per million. Now they're got down to 180 in the last glaciation. We're bouncing along at the bottom. They're just about to die out. We saved this planet by digging up all that coal. Now that's the good news. The bad news is that we can only get to 600 parts per million. If we dig up every rock that we can burn economically, we'll only get to 600 million. And the other thing to bear in mind is the top 100 metres of the ocean are separate from the rest of the oceanic column of about 3,000 metres. So the half-life of a CO2 molecule in the atmosphere is 5 years. Carbon dioxide is so soluble it goes in and out of the oceans continuously. And that was first proved by the atomic bomb testing in the 1950s and C-14 and so on staying in the atmosphere. Now the oceans turn over in 800 years. We'll get to 600 parts per million, everything will be wonderful, and then the oceans will simply suck that CO2 down because there's 50 times as much CO2 in the oceans as in the atmosphere. There'll be a partitioning, and we'll end up only 2.5% more 1,000 years from now than what we were started at pre-industrialisation. And a lot of places will go back to being deserts. West Australia's had about 30 to 40% plant growth increase in the last 20 years because of CO2, a lot of the stuff up into the Pilbara. It's a wonderful story, but it's good and bad. Thanks very much.
Can I be heard? Can you hear me? Well, thank you very much. This was very interesting. It is a little bit tradition that the moderator has the first shot in asking a question. Now, I have a lot of questions in my mind because we'll be talking about two different things here. Number one, is there global warming? And number two, are there strategies justified to deal with this? What I will do, I will only ask one question, and please feel free to whoever wants to answer this. I'm not going and taking time of your question time because I'm much more interested to hear what you have to say. But I am a little bit concerned about the strategy to reduce livestock head, as Holland has done it, as New Zealand is planning to do this. And I really would like to understand how dangerous it is to keep cattle for our CO2 thing. Who would like to answer this? You would?
Yeah, I can address it. Look, it's not a subject I'm an expert at, but I am aware of research papers that suggest that you can, if you're referring to the carbon emissions of cattle through methane, that can be reduced, I have heard, by feeding them seaweed. Now, why cattle would want to eat seaweed, I don't know. But all I can say is it's definitely not Sidious One policy to reduce livestock. I can't imagine that happening in Australia.
Okay, I will give this microphone now to Norm. Norm is now ready to ask questions from you, from the audience.
Okay, thank you. So, yes, so if anyone's got a question, if you can put your hand up now so I can write, so I'll try and keep some sequences. And please also remember, with your questions, first of all, let's give a round of applause for all of our I think this topic can be emotional, and I'm happy that we're here, but I'm so thankful to all four to come here and to talk to us. And that's what our focus should be, our thanks for that. And let's reflect that in the way we ask our questions. Okay, so I'm going to select our first question from the front row here. Do you know who you want to ask your question of? No. Okay, well, you ask the question and I'll see if I can work out who it should go to.
How did climate change start?
Okay, so how did climate change start? What's your name?
Matilda.
Matilda. Okay, well, thanks for being here. Have you enjoyed this?
Yes.
Okay, all right. So the question is, how did climate change start? And how about we start with Professor Newman, and we'll also give a turn to perhaps David to answer that.
David's the geologist, and climate change started eons ago, billions of years ago. That's the way the Earth has been shaped. What we're talking about are human interactions in that cycle of life that has been created. And so the only thing that is on the agenda for us tonight was about whether human-made climate change was real. And that process actually is pretty old too. You can go back into the Bible and see how cities collapsed during periods where there were changes to water and atmospheric things, and for example, some cities that cut their forests down for their war machines changed the nature of the flow of the rivers and they collapsed. That's the kind of thing that you can see in ancient history right through. So we've always interacted with our climate, but the big change has been the burning of fossil fuels, and it's taken us some time to realise that that is something that needs to change, and human beings are pretty creative and innovative, and I think we've solved it.
How did climate change start? Well, we're up to, there was Professor Arrhenius in the 1880s, a Swedish bloke who said carbon dioxide heats up the atmosphere and it'll be 3.5 degrees from the effect of fossil fuels. And that sort of died away for a while. And then in the 40s and 50s, the world was actually cooling. The Thames froze over in 1962 up at Oxford. And it looked like we were going to continue cooling into a glaciation. Now, bear in mind that the world is about 2,000 years out from the next glaciation started. We are 12,000 years into the Holocene period, which is an interglacial. The interglacials come along every 100,000 years. And then another 2,000 years, this is going to be the longest interglacials from the last million years. We'll be plunging into a full-blown glaciation, not a lot worse than the Little Ice Age. And anyway, what happened then after the 70s, when it was very cold, those same scientists who were saying we're going to go into a cold period turned around and said we're going to start warming. Same ones. And then the momentum picked up in the 1980s, and then we had Rio in 91, and then it all took off. And what happened in Australia is that John Howard, as Prime Minister, wanted to force nuclear power on the country because he didn't think that we would vote for it ourselves. And so he started the whole process of down the carbon tax and the National Greenhouse and Energy Reporting Act of October 2007, after he had lost the September 2007 election, because we were basically held in contempt. They're going to try and force global warming on us to bring in nuclear power, and we still don't have nuclear power. We won't have any sort of power, and we'll be all poor and destitute.
Okay, so our next question, if you'd like to say your name and who your question is to.
My name is Greg Smith, and can I sort of have 3 questions in one? One, all right. Staying on. My question is, to Dr. Newman. Oh, not Dr. Newman, Professor Newman.
That'll do.
We've got it's all started as global warming. That was the very start of the whole theory. And the worst time the world's ever experienced was when it got colder. Why would we, if climate is going to change, surely getting warmer would be better than getting colder? Because it'd be naive to think that we could actually control the temperature of, it'll be in 5 years' time or 10 years' time.
Okay, so to summarise, I think the question is, isn't getting warmer a good thing?
I like to be... That's okay. I get it. I get it. I like to be warm. I don't like the cold. But that's really nothing to do with what we're talking about in this whole debate, because it's not about how you feel or how the general atmospheric temperature, the daily cycle of whether it's warmer or colder. It's about how much energy is in the atmosphere. So global warming wasn't quite what it was about. It's about increasing the energy in the atmosphere so that you get more evaporation of water and higher levels of that going up because hot air rises. And that means you get more storms, more extreme storms. When Katrina hit New Orleans, the average temperature of the Gulf of Mexico had gone up 5 degrees and it was really evaporating, so it was going very high, and it came in with this incredible storm, and that was a 1 in 100 year storm, and they've had 2 since. So that's the problem. We're getting more extreme events more frequently, and that is what we're worried about and how we can ease the problem of that extra energy in the atmosphere is only by getting CO2 levels down.
Thank you, Professor Newman. I think if you'd like to stand up for the camera.
I'd like to ask Professor Newman. My name's John Hartnett. I'm a physicist, retired professor of physics. The timescales in which you are applying your models are timescales much longer than human lifetimes. And that's probably why geologists reference the geological record. The question I want to ask, though, is how do you account for or mitigate against human bias in choosing your models and choosing your data sets? Because let's not fool ourselves, humans are extremely biased and tend to apply their particular choice that favours their particular ideology.
Thank you.
Yeah, humans are inherently biased and constantly need to talk to other people to see where their bias is and to learn from it. That's the IPCC process. And what Norm's trying to do tonight, right, Norm? And the reality is that there are about 12 big modelling groups. Do you want to listen or not? Sorry. Are you roaming around trying to get someone to give a question or what?
Just taking a tally. No, but I'm interested in...
Oh, there's a tally, okay. All right. The 12 big modelling groups around the world get together regularly to compare and say why they're wrong or right, and they constantly have these arguments. And in IPCC, it's a constant process of seeing what works and what doesn't work and what is biased and what's not biased. That's the kind of debate we constantly have. And it's the same with all of the various theories that come out, that some of which have been mentioned tonight. We look at them all, and we do find that eventually you can come to a point of saying what seems to work. And each year you look at it again. So for 1992, it's now 20 years of IPCC work on this, and the models seem to be getting better. But I still don't worry too much about those models in terms of how quickly we can change, because that is a human value that's put into these models. And mostly they say, oh, it'll be 50 to 100 years before we can really get over this issue. And that to me is not the way human history has worked, because generally once we get hold of a new innovation like smartphones, I mean, we didn't predict from models that we'd get smartphones and everybody would be using smartphones. It happened so quickly, and it took off. Every Maasai herdsman in Africa's got a smartphone now. So it's very quick that you can get these changes. And I back the technological optimists who say that we now have the wherewithal to make these changes much quicker than the modelers have thought, because those human issues, they're there, they are there. And I hope we will be very surprised in 10 years' time when we look and say, look, we are so much further down this track than the modelers ever thought.
Thank you, Professor Newman. So people who have a question, can we come and just line up here? And I'm going to ask, because we've got a few questions, if we can make the questions short and to the point, and when we get the answers, likewise, so we can get through as many questions and answers as possible. So, start with your name and who you're addressing the question to.
Okay, Paul Jones. My question is really, because we spoke a lot about carbon in the atmosphere. What is your target level? You keep saying we need to reduce carbon. I need to understand, what does that mean? What are you trying to get to? Obviously, we spoke about 150 that the plants start dying, so obviously that's a little bit too low. So what is the actual target that we are aiming for?
Thank you for that question, because that, to me, is a really important thing to understand where we're at on this. What the Paris Agreement came up with, and 196 countries agreed to this, because the business community and the environmental community got together before it and said, look, we think this is what you should do. 196 countries, so 2015, 2016, they adopted it. 2050 to be net zero means no more fossil fuels apart from some that will be neutralised by planting more trees and stuff. So it is a matter of having zero effect on climate, okay? You're getting me so far? That was the first step. The second part was they said, let's try and get this earlier, 50% by 2030 is what they said. Now that was thought to be too hard by most places. But in the last 3 or 4 years, the finance world has announced this policy of $170 trillion only for net zero projects. So everybody's flocking into it very quickly, and it's happening very much quicker. So people are competing now to see if they can do it quicker. Twiggy's saying, oh, we can do it by 2030, no trouble, 100%. And the big thing is this. Each year after the Paris Agreement, there is meant to be a meeting of the parties, all the countries come together to try and ratchet up their commitments. Australia was not doing very well. We've now committed to 43% by 2030. That's actually quite strong in the world's situation. But there are other countries that are going further than that. All the state governments have gone for 50% or more by 2030. And this state government here has said 80% by 2030 in everything that the government owns. Now that includes local governments. I don't think you've quite got that one yet. You're supposed to get to 80% by 2030. That's what they've said they're aiming to do. So every agency in the government, the public housing, the public transport, they have to meet 80% by 2030. That's only 8 years away. So there's a very rapid change. Now this is not a government that, the state government, that would say is highly committed to climate change. They've been pushed every step of the way. But the reason they're doing it is because the power system is so quickly getting rid of fossil fuels without them having to buy a single bloody thing. We're buying it and putting it on our roofs. It doesn't cost the utility anything. All of that solar is going in. 1 megawatt a day is going in. So it's going to be very, very quick. Now, you think that those commitments are too fast or something, but the reality is it's happening.
My question was, what's the target? Yeah, you're talking about the reduction and reducing reduction, but I want to know what target are we trying to reach?
Oh, okay. That is the Paris Agreement. The net zero by 2050 is in order to keep below 1.5 degrees centigrade rise. If you go to 2070, by the time you get to net zero, then it'll be over 2 degrees.
How many parts per million is that?
Well,
We got a lot of questions.
all of those parts per millions are there in the Paris Agreement. So you can Google it. It's a one-page document. You can see it there.
So we'll keep going with the questions. Remember, say your name, make the answer as, yes, as short as possible. The question as short as possible, but also when you answer, try and, because I just want to get through as many questions to as many people as possible. So yes, Joe, if you'd like to answer on the affirmative to that question, that would be great. But if we could keep it short so we can get through, that would be great too. Thank you.
3 affirmatives really quickly. Warming is net beneficial. We look at the crop yields around the world, they're all at record highs. World population has increased. The more colder the world gets, the less food we can grow, the less arable land there is, the more frost we get wiping out crops, and the higher food prices go. So at the moment, warming is, and where do humans live? Humans live in the tropics, they live in warm climates. People don't go on holiday very often at the poles, they certainly don't go and retire there. So and for that first point, we actually get a more extreme climate in a colder world. When we have a colder world, moisture drops out of the air. So we all know when the clouds and the humidity go down, you get more extremes of temperature, higher highs and lower lows. You get, the Great Storm of 1709 in Great Britain was when CO2 levels were ideal and the world was cooler. And it was a shocking 9-day storm that killed thousands and wiped out a lot of the fleet. It was a disaster. So great storms and extremes happen in a cold world. Now, the IPCC, the next question was about confirmation bias. The IPCC has no auditing, there's no formal checks on it. There is no one paid to make sure they get the science right on this. There's only people paid to find a crisis, and you'll find that in the mission statements there. You'll find anyone who disagrees gets sacked from universities. Look at Bjorn Lomborg, he's not even a scientist, an economist. He agrees with most of the consensus. He simply wanted to discuss the costs. Tony Abbott tried to give him $4 million, and our local university, University of Western Australia, had to knock it back. Even for $4 million, it was not worth letting an international economic expert set up a centre in WA to dare say that things were too expensive. Now, moving on to the next question. And if we want debate, surely we pay people instead of expecting volunteers like David and I and thousands of people on the internet to spot holes and flaws in what the BOM and the CSIRO and the ABC and everyone else say. You know, we do it for nothing because we believe it's right. Now, on the forced transition, the subsidies, solar energy that everybody's putting on their house roofs is subsidised by the government. The subsidies were coming for years through the LRET and the SRET and being put on roofs, and people didn't know it, but their neighbours were paying a subsidy for the installation. They would phone up the solar installer, and the solar installer would say, sure, we can do it for this many $1,000s, and they'd pay the money thinking they paid the whole cost. But actually their neighbours who didn't have solar panels were subsidising the cost of those solar panels through their electricity bill. It's hidden in the bill. You don't know it because when you get charged, your electricity bill doesn't have a label on it that says, this is what you're paying for other people's solar panels. So our electricity prices overall have risen because the costs of the solar panels have been shared amongst all the users. Even the poor people who couldn't afford to put solar panels on their homes are paying more expensive electricity so rich people can put solar panels on their roof and get cheaper electricity. Now figure how fair that is.
Okay, next.
Yeah, hi. Yeah, my name's Chris. There's something I think Joanne and David might agree with me, is that the water they're talking about is a greenhouse gas. It's about 3 times the power of carbon dioxide because there's more of it in the air. But it's not a driver of climate change. Like the water vapour, as most of us probably know, it goes up in relation to the temperature of the air. And then there's a bit of a roll-on effect, but it's not something that just goes up of its own accord. There's got to be something else that's heating the atmosphere, enabling it to collect more water, which then becomes a positive feedback event. So if anybody was thinking something's weird's going on and the water is going up and cooking the planet, no, it's just going up in response to greenhouse gases or whatever else is in play, warming the atmosphere.
Thank you, Chris. I've got a question from the audience, from some of the live stream audience, and I'm just going to move over here to get that. So just for everyone else, and to get it on for the recording, when hasn't the climate changed, and wasn't it hotter during the Triassic period? Is that correct?
Yes, and also, if water vapour is an alleged greenhouse gas, should we tarp the oceans?
Okay, so if we can have an answer perhaps from both sides, but if I can ask if it can just try and be as brief and as to the point as possible. Thank you.
Yeah. The geological periods are not what we're discussing in the IPCC or anything to do with human-induced climate change. It is the last 10 to 15,000 years that we have had cities and agriculture. Before that, we had very little settled civilization. That's the period when the average temperature was around a 1 degree variation. Outside that, there are large variations that geologists like David look at, and you can learn from them, but they don't actually help us in our discussions about how we keep within that 1 degree, because that's how we know how to make cities and agriculture work. And we're going out of that safe operating space. That's the problem. We're going above that for the first time in 10,000 years. That's the era. We've had the odd times, of course, but it's the average and it's the rapidity of which it's going up. That's the problem.
On the subject of the Triassic first, there were glaciations in the Triassic, but the Triassic is best known for a whole lot of dry periods and then wind-blown sediment. In terms of the scale, time scale that Professor Newman is talking about, be aware that 15,000 years ago, the shoreline was 4 kilometres west of Rottnest, 120 metres lower than it is today. And then along came the interglacial, sea level rose, it all got warmer, and the peak temperature was 8,000 years ago, and it was 1.5 degrees warmer than it is now. We've been cooling at the rate of 0.25 degrees per 1,000 years since that peak of the Holocene period. Sea level was 1.5 metres higher than it is today. So to put it into context, what the IPCC are afraid of is returning to conditions of 8,000 years ago.
My name is Vic Power, and I've got a very simple question, and it's probably directed to Joe. This is the reason I've come here tonight is because this is the first time I've actually seen an attempt at a balanced discussion or balanced debate on this subject. Joe, in the 20 years that you've been pursuing this issue, how many times has the ABC attempted to present a balanced debate on the subject of the climate emergency?
That's a really difficult question in the sense I don't think I can remember the ABC putting on a proper debate. They've invited me on Q&A a few times, which I declined to go on because it was never about climate change that they wanted me to talk about. It was always when other issues were there. I think so they could trap me on a different topic and then claim that I was some evil racist or something like that. So David and I were invited to go on a ABC documentary 10 years ago where Nick Minchin and Anna Rose came and filmed at our house. So there was an effort at debate then, which was nice. But if you looked at the film recording that they did from our house that day, then we got 2 hours, I think, of footage, which they condensed down very short. I spoke, 2 hours worth of conversation, and they pulled out 26 non-sequential words where I kind of laughed a couple of times, and they took my husband's words and actually edited him so that he said something, a sentence he never said. That's how desperate the debate is, and we ambushed them with cameras because we thought they would do that, and they still did it. So where's the honesty? They're really afraid of a debate, and the reason they're afraid of a debate is because the sceptics have all the answers, all the data, and the information on our side, and we don't have to resort to things like name-calling or righteous indignation to be able to defend our position. And I just want to make the point too, which we haven't really said, CO2 is a greenhouse gas, it does absorb, it is causing warming, and there has been warming, so we agree with all those things. The thing I disagree with is the fact that CO2 is blocking a little bit of energy from escaping, but energy has so many other ways to escape. It's a river of energy passing off the earth, and we can block a bit of that with CO2. Well, what do rivers do when you put an obstacle in their path? They find another way around. So we should be looking to get models that work before we spend $50 trillion on redoing our energy system, an energy system that worked really well before we started putting climate change onto it.
Okay, so Mark, your question.
Thank you, Norm. Yes, my name is Mark Lofts. I'm a retired doctor and independent researcher. And my question is just to address a couple of these issues. As a person old enough to remember, our seasons are earlier than they used to be, our plants flower earlier, birds nest earlier, and glaciers are melting. And I've been overseas and seen melting glaciers. And I do disagree with Joe a little bit, saying that what's going on and why I'm not afraid of global warming, even though it's real, is because the global warming is being reversed by the melting of the Greenland ice cap, leading to a rise in sea level of about 3 millimetres a year, which will rise to 4 millimetres a year. I asked the climate panel, are you really worried about the next 10 years with a 4 centimetre rise in sea level? Perhaps the Kwinana Freeway might worry, but I just wonder what people would like to say about that.
Yeah, I do worry about it. It's not that gradual stuff, it's the extremes. So the storm surges will get higher, more extreme, and that's the issue that Pakistan has covered. 2/3 of their country were covered. That's the kind of extreme we're talking about, not just the odd centimetre or two rise. Certainly the ocean is rising, and we've had measurements at Fremantle Port for over 100 years, and it's gone up about that much. So that's not the issue. We can cope with that. It's the extreme storm surges that are likely to cause damage. And we will get cyclones coming further south. The heat from the tropics is going up and coming further south and going further north. That's why it's causing these bigger issues. So we will get cyclones coming down into this region, and there will be storm surges and flooding that will come from that, as well as times when we'll get over 50 degrees heat waves. They're the issues that we need to try and come to terms with. But overall, we're not going to be the place where most of this change occurs. There's a lot more serious parts of the world where there's a lot more people living that are being affected, and that is the issue that we're trying to address at the same time. It's an equity issue as much as anything. Can I just say one very quick thing? Joe's mentioned this subsidy thing of PVs several times. She said the PVs were subsidised by about $2 billion. That sounds a bit more than I think it is, because it's a very small amount that you get a subsidy for a PV on the roof. Fossil fuels are subsidised by the federal government $30 billion a year. You know the diesel rebate? $30 billion is the known figure. The diesel rebate for agricultural and mining purposes, they get 50 cents a litre less, right? That's a subsidy.
Because it's off-road.
Yeah, I know, right? But it's a subsidy, right?
No, it's a road tax.
$30 billion.
Because they didn't hold to make it.
Ladies and gentlemen, I disagree respectively that the diesel rebate is a tax. I think is a subsidy. I'd say it was a tax rebate. The people earned the money and they got to give less of it to the government because it wasn't involved in driving on the roads, as you were saying. And that most fossil fuel subsidies, they're dwarfed in comparison to the subsidies. Look up Alan Moran's list of subsidies in Australia from the government, from state and federal level governments. And he estimated at least $5 billion a year was being spent on subsidies to solar and wind. Now, there are lots of other subsidies to them, things to do with the transmission lines because they need to be out at far distant remote locations. The subsidies of frequency stability on our grid, we took all that for granted. It was given by coal-fired plants. We didn't even think about it. We've had to set up a whole market for FCAS, frequency control stability, so that our grids don't crash and fall over. We need backup, and the backup is got to be good enough to run the grid, because solar and wind collapse down to a mere 2% of their total capacity once or twice every month. So we end up with this low-running choke point, as Rafe would say. Thank you, Rafe. And we've got to have a fully backed up grid for our intermittent renewables. If you've got the fully backed up grid, just run it off that. You don't need the renewables running on top unless you believe there's a real benefit to cutting CO2. And if you really believed you wanted to cut CO2, you'd put nuclear power in, because that's the only sensible baseload provider of low carbon energy. Why isn't anybody interested in cutting carbon with nuclear?
Okay, so I think we could have another debate on subsidies and tariffs. So we're going to have 6 more questions. Please, really short, direct to the point, who you want to ask the question of, and answering short and to the point, and then we need to wrap up.
Since I'm the only
Yes, we will extend you to be number 7. Because I like her, so I'm going to help her.
Yeah, but not on the basis she claims to be a woman.
Hi, Michael's my name. My question's for the climate panel. In 1990, the IPCC determined that the observed surface temperature of the Earth was 15 degrees. Then in 2007, they determined that it was 14 degrees. If the IPCC can't measure the temperature of the Earth, why should we trust the science that they can have a model that can predict the future temperature of the Earth?
Can I ask where you got that from?
Yeah, I've got it from some reports from the IPCC's website. I can show you on my phone.
Okay.
Downloaded. This is by the IPCC itself.
Yeah, because there are 31,000 weather stations around the world that are coordinated to give average temperature for the water, the earth and the air, and they are brought together to get that average temperature. I don't understand were they correcting a figure from the previous year, or is that what they were saying? I don't...
There are, the people on the other side can tell you, there are quite a lot of publications, journal articles and news journals that looked at this subject, and they were called Why is 14 the New Normal? Or Why is 14 become 15? Something
Yeah,
like that.
why I asked is it sounds very blog-like rather than published papers that we review in our process in the IPCC. So that's all I'm saying, is that there is an enormous amount of scientific effort that goes into getting those numbers.
Okay.
My question is also for Professor Newman. My name is Alexander. I'm an electrical engineer. My question is, why is the focus of the climate lobby mostly focused on intermittent peak power sources like wind and solar instead of base power like nuclear? I lived in France for a few years and my power bill from the EDF was a lot lower than my power bill from Synergy.
No, not anymore.
Yeah. Look, it's this is the electrical engineering profession is changing very rapidly because of these solar and wind being so cheap that they can... Look, they are cheap. They are so much cheaper, Joe. I don't know where you're getting your data from. Everybody can see it. It's very cheap. Go and talk to anyone who's in the utilities these days. They can see how cheap it is everywhere. You tell me one that isn't buying solar and wind.
Denmark, it's not cheap. Germany, it's not cheap.
Well, right now it is, because the price has come down and down in the last few years, and it's certainly cheap here. The reality is that we now need to balance that, all right? We have to be able to balance that so that you meet the demand. That's the process that the state government is working through in great detail. They've got a lot of community batteries. They've got a lot of storage systems that they're getting into the system to try and enable that to happen. That's the process we're going through over the next 5 years, which should enable us to have a stable and baseload power system as well as the intermittent sources. But the intermittent sources are driving the change because they're so cheap.
G'day, Andrew. Apologies for not being here from the beginning in case this has been covered. I'm curious if anyone could discuss a bit further in 3 areas: the magnetic poles flipping, chemtrails, and thorium nuclear power.
Okay, so there's a lot to unpack there. Yeah. But how about if we just get something from thorium? David, would you be able to? Or Joe, could you say? Yes, on thorium as a potential nuclear power.
There's 4 times as much thorium as uranium. But the problem with thorium, it needs 2 stages of breeding to make it into U-235 before it's fissile. And you have to do that in the thermal spectrum, not in the far spectrum. It's only got an 8% breeding ratio, whereas plutonium breeder reactors have a 30% breeding margin. So you can easily lose all your neutrons in the walls of the reactor and everything. It'd be much, much safer and simpler to go through sodium-cooled plutonium breeder reactor rather than try to commercialise thorium. We're running out of time as a civilization to get nuclear power sorted. And the combination of plutonium and thorium one day may extend our nuclear reserves 5-fold from what they are at the moment. But that may come. That's all.
Thank you, David.
My name is John. My question is going to Dr. Newman. We've heard that the IPCC is supposed to be the authority on climate change. Well, as a retired geoscientist, I've been following the IPCC since 1988. My question is, why have so many scientists resigned from the IPCC process, making comments such as this? This is Dr. Vincent Gray. The IPCC climate change statement is an orchestrated litany of lies. That is just not a sole comment. I've got 50 such comments here, if Peter Newman cares to read them.
Yeah, look, there are some people who have resigned, and I think it's sad that they don't stick around to work out their ideas, because everybody else does disagree. There's lots of disagreement that happens, and we work it through. There are a lot of geologists who have not stayed in the IPCC because they prefer to have a much longer time span, and that's not what the IPCC is set up to do. So that's one of the reasons, and they prefer to have that perspective that it's all, humans are going to disappear anyway, so it doesn't kind of matter. That sort of approach is not what nation states get elected to talk about.
Quite a few atmospheric physicists have resigned.
Yeah. I know. We hear them. We hear their stories. We're not cut off from the world, you know. We do have these statements that come to us, but every time we get our reports reviewed, those kind of statements come in again, and we have to answer them, and they are answered and reviewed. The reviewers' comments taken back to them, and they are all published. You can read all of the reviewers' comments for everyone who disagrees. They are there. It's not like we're running away from it.
Good evening, folks. Panel. Look, I felt compelled to actually speak. I wasn't going to, but just let me say, look, I've got a farm, and let me say that in the last 2 years, and I know things are cyclic, and there's a very small percentage of time that the Earth has been around, and my 2 years, in the last 2 years, we've had bumper crops. And if you've got any more greenhouse or warmth for my crops, well, bring it on, please. I'm pretty happy about that. But that's not my question. I know that last year we had a 24 million tonne yield in crops, and this year we're going to smash that. Okay? So the reality is that whatever is happening is bloody great at the moment. But what I will say to you is this: I am extremely concerned about the UN's involvement in all aspects of our life, whether that is bringing up our children or it is actually advising on cattle. And it just seems that they keep nailing and keep talking about, as our beloved councillor over here was talking about, about cattle and the fact that they are burping and farting and goodness knows what. And I'd just like to know, why is it that you're zoning in just on cattle? I breed sheep, I breed horses. And let me say to you that, it is a real worry that the IPCC and the UN are doing all sorts of research for eating bugs and all that sort of stuff. Why are they zeroing in on cattle? And why is it that even here in Western Australia, they're talking about a product made out of seaweed called ruminate, so that stops actually the cattle? It's from, as far as I'm concerned, it's just a bloody beat up.
Can I just say, look, I reckon it's fantastic what the farmers have done in West Australian wheat belt and the pastoral areas where the crops and the harvests have been incredible. And over the years, there's been a lot of science has gone into how to make that happen and to enable that. A lot of very clever, very committed, hard-working farmers, of course, and we all benefit from that. And I think it is incredible that we have continued to grow in this, and in a time when the world needs these as well. So you're getting a good amount of money back for it. And I think you will find that you will be able to survive the UN's statements about farting cows. That is actually being pushed right out. It's very difficult. New Zealand still hasn't faced it. And that kind of process is going to continue. It's not solved. I don't think it's solved. But anything that can get solar and batteries and electric vehicles, you'll get electric tractors in no time. They'll all be better and everything. Quite seriously, they will be better. And that's already happening. The trucks, the trains, they're all going to do it. So it will be a process of change, and eventually I think they might find some way to manage that change for you. But it's not as though you haven't had changes in agriculture over the last 20 years in terms of the fertiliser that's used, the cropping techniques, the whole mass production processes that have been implemented. It's been a change process, and farmers have done well, and I think they'll continue to do so.
On the subject of methane, I believe the current level is 30 parts per billion. Now, carbon dioxide is currently 420 parts per million. So at 30 parts per billion, we're looking at a level that's 1/10,000th the level of carbon dioxide in the atmosphere. So anybody who's worried about something that's quoted in parts per billion is talking complete nonsense. They're trying to lead you astray. The half-life of a methane molecule in the atmosphere is 30 years. So it gets oxidised very rapidly. And the greatest source of methane in Australia is termites, and on planet-wise, they produce far, far, far more methane than all the cattle and sheep and all the other things. Because just about every stick of wood that gets grown in this country falls to the ground, gets eaten by a termite or some other thing, and produces a hell lot of methane. No one worries about it. The only reason why we've got a beat up on methane, and our federal government just signed some international methane treaty, there's no worry about, don't worry about the details, it's just all the great nonsense. Absolute great nonsense, relying on people to believe what scientists say uncritically.
If you get two litre Coke bottles, plastic Coke bottles, and you put one in the freezer for half an hour, put the other one out in the hot sun for half an hour, take them into the laundry and lift the lid, the fact that the hot one fizzes more CO2 coming out of the bottle, is that not sufficient evidence to prove that it's temperature that causes CO2 to come out of the ocean, rather than the cooling of the planet absorbing CO2 into the ocean? So it's temperature causing CO2, not CO2 causing temperature.
Yes, Henry's Law, and the ocean absorbs 50 times as much CO2 as is in our atmosphere, so you are absolutely correct. And as the oceans warm on their 1,000-year turning cycle, they release the CO2 back to the sky, and as the world cools, they suck that CO2 out of the sky, which explains the Vostok ice core graphs and why there was about an 800-year lag in terms of temperature rising first and CO2 rising second, and then as it fell, it took thousands of years to suck that CO2 out of the sky. And just talking about crop yields, the CO2 is a fundamental basis of carbon life forms, because we are carbon life forms, and those plants have evolved over 400 million years to be really clever at sucking out that CO2. And that the CO2 comes out of the air, not out of the ground, when plants draw it down, and so putting more of it in the air is in fact really good for plants, and it is what market gardeners do. Carbon dioxide is called pollution. It's part of a propaganda campaign. The only pollution we know of on Earth that farmers buy in large bottles and pump into market gardens to feed their plants, so they increase their crop yields by 30 to 40% inside those market gardens. How do we call that pollution when our plants are depending on it and it's healthy, and we are carbon life forms, ladies and gentlemen?
Okay, so
we don't call it pollution.
Only all the time.
No, you just read the IPCC reports. There's plenty about how CO2 improves plant productivity. It's there. It's clearly stated. It's not a problem. It's the temperature that matters.
Okay.
I just have to say, yes, the IPCC may not call it pollution, but hundreds of people on television call carbon pollution. They demonise the sixth element of the periodic table, and none of those IPCC scientists stand up and tell the ABC off when it does that. When are the real scientists in the IPCC going to stand up and start saying it's not okay to use the term climate denier, it's not okay to call carbon pollution, and we need an accurate, friendly, civil debate, because science depends on civility just as civilisation depends on science.
So we're up to our last question, and I'm hoping this is for Ian.
Well, it was actually, my name's Helen.
Yes, it's on.
My name's Helen, and I'd like Joe to address this, and perhaps Professor Newman. In 1942, some Allied bombers were flying over Greenland, and because of a blizzard, they had to land. The airmen were saved, but in 2011, using solar, one of these planes was located under 300 feet of ice, which suggests that the glaciers are being replenished. So are the glaciers actually melting or not? Thank you.
The latest data I saw was something like 3 or 4 are replenishing, and the rest of them are not replenishing. They're diminishing, and that data is very carefully kept across the world. It is one of the ways the scientists assess whether or not global warming is happening.
Regarding the Greenland ice sheet, ice is falling in the centre of it, and it all flows out to the margins and then carves out in the glaciers and so on. The low in the Greenland ice sheet in terms of ice mass was 2011, and it is now increasing. And if you look at total northern hemisphere snow mass, that's gone up a hell of a lot just the beginning of this year, and we'll see that trend continue.
There you go. Hey, you got it.
Can
Can you believe? I can give you an answer from personal experience, not as a councillor, not as a firefighter. But long before I moved to Australia, one of my hobbies was mountaineering. So I've been mountaineering in the Alps and in the Himalayas. So I'm very familiar with the glaciers there. And I can assure you, from looking at them firsthand, they are definitely shrinking.
So thank you everyone for your patience and for the fact that you came here and you listened. I get that a lot of you feel passionate, and I think that's a good thing. And I think the fact that we were able to be here, and we disagree, but that we could be civil and discuss things. I certainly know that I have learned a lot tonight, and I've learned it from all sides. And that's our objective. So I want to say thank you again to all 4 of our speakers. I just so deeply appreciate the fact that you came here. And I know we had a few moments there, but I hope that maybe if we tap you on the shoulder in the future, you might respond positively again, because you've been wonderful for us. I'm going to now give you some results of some surveying that we did, both when people came in and when they, at the end of the debate. Now, I was rather surprised at the figures, but I will tell you that before the debate, there were only 14% of people who agreed with the moot of the debate. 70% disagreed, 14% agreed, 72% disagreed, and 13% were undecided. After the debate, agree was 15%, disagree was 70%, and undecided was 15%. So I have to declare the winners of the debate, the affirmative side, for tonight.
Because one person changed.
Well, we can have the undecided, we're co-winners, but in a debate, one of the teams must be declared a winner, and tonight the affirmative side were the winners on the numbers. So I really appreciate what you had to say. I don't think it's that important. I think what I take away from that is the fact that people moved and people changed their thoughts. And that shows us why we need to do this, why we need to be together, why we need to face each other and do that without fear, knowing that people disagree, but that we can be that way. We don't have to be polarised, we don't have to be enemies to each other, and we can leave still disagreeing, but as long as we learn from that exchange. And that is the way we progress as humans. So thank you all again. Thank you to the team who put this together. Thank you to the speakers. Thank you to Brigida. Thank you most of all to you and my lovely wife down the back. Yes, that's right. Yes.